Okay, so welcome back. Now we're going to start with part 1, which is scope, object, and fundamental principles. So this means what is within the range of the book. Scope, does the book apply, does it not apply? Object, what the book's going to do. Fundamental principles, how it's going to do it. Simple as that. So there will always be. Let's remember that the exam is in order. All right. So I said in the introduction video, I'll mention the exam if needed. This is where you're going to start in this area. So with regards to scope, we've got 110.1 general, and it just says regulations apply to the design, erection, and verification of installations such as those of, and then there's a long list. So we have residential, commercial, industrial, medical, prefabricated buildings, low voltage generating sets. We've got outdoor lighting. We've got caravans. If you're familiar with the regulations, then it's basic systems plus special locations, really. Okay. The new one for the 18th edition, obviously, is this one at the bottom. I'm actually in the way of the onshore units of electrical shore connections for inland navigation vessels. But these are all types of electrical systems that are inclusive of the scope of BS 7671. Yeah. Now, it also then has 110.1.2. This says the regulations include requirements for. So instead of types of system, this is types of circuits. So it's not types of system, types of environment. This is types of circuit itself. So it applies to circuits up to 1000 volts AC or 1500 volts DC. Okay. It's for circuits other than internal wiring of equipment operating at voltages exceeding 1000 volts and derived from an installation having a voltage not exceeding 1000 volts. So we can supply a circuit that achieves a voltage over 1000 volts, but the wiring system itself supplying the equipment shall not exceed 1000 volts AC and 1500 volts DC. Because that's when we go in the wiring regulations from LV to beyond, so HV, I guess you could say. It also has wiring systems and cables not specifically covered by the standards for appliances. So if you have a piece of electrical equipment or an appliance with no applicable standard, then this can come into there. All consumer installations external to buildings, fixed wiring for information communication technology, and additions and alterations. Okay, so those are the types of circuit as well that are inclusive of scope. So that's scope. There's a general list there. All these types of systems are inclusive, and the type of system. Now we also have 110.1.3. Now, what 110.1.3 is about is where generally BS 7671 is applicable, such as selection and erection, wiring systems, methods of erection, commissioning, things like that, protection even. But, it says here, generally, but in certain cases they may need to be supplemented by the requirements of recommendations of other British or harmonised standards, or by the requirements of the person ordering the work. So, by them it being supplemented, it means the BS 7671 may need some support from a finer area that will have either more technical regulation, more technical information, more technical standards, or just a coverage of scope not covered in BS 7671. So, some examples here. Oh well, here's the obvious one there. Emergency lighting, BS 5266. So when we think about emergency lighting from our BS 7671 perspective, it will tell us about the wiring system needs to be segregated from all other lighting and power. It will tell us that the wiring system shall not go through an explosive, an area that's exposed to explosions, but should also not go through a fire area. It'll also tell us that there's a classification, so a change over time. Medium break, no break, very short break. It'll also tell us that there's that there's sources of safety services, primary cells, batteries, and things like that. When it comes to BS5266, there's more information, and that's with regards to duration, due to time, due to lux levels, due to space, due to passing width restrictions. So there's a lot more into it that you need to, if you're involved in emergency lighting systems and you're doing a design of emergency lighting systems, the range of BS5266 is very important. And so they supplement BS7671. And if you look at the other standards here, we've got explosive atmospheres, fire detection and alarm systems. We've got, this is one I do other training in, the temporary electrical systems for events, entertainment and related purposes, BS7909. Now, many electricians install temporary systems for clients to run events or to run an exhibition or whatever, sometimes with little to no idea about BS7909 because they've not looked for it or they've not been made aware of that. But BS7909 gives us types of cabling. For example, Arctic Blue, not allowed that in BS7909. It'll have to be H05 or H07, especially if outdoors. It'll give us proper certification. For example, in BS7909, there's a requirement with inspection testing for you to verify the respective short circuit current at the final point of utilization, as well as the earth fault loop impedance. So there's additional test requirements. There's also selectivity requirements with numbers of RCDs needed at different positions within the ICUs and the other terminology that they have in BS7909. So there's a tighter level of control and a much tighter level of certification, and there's dedicated BS7909 certification. It's not BS7671 certification. There's a dedicated certificate type in there. And if you aren't familiar with that, you need to obviously seek further understanding or technical information on that one. But if you ever put in a temporary supply for a client, then you want to have reference to that standard there. So those are supplementing BS7671. They're supporting it. Okay, so we had the inclusion of scope. We then need an exclusion. So that's 110.2. What types of system are not included? So we've got distribution for electricity to the public. We commonly refer that to ESQCR, the Electricity Safety Quality Continuity Regulations. We have motor vehicles, ships, offshore installations, aircraft, mines. These are higher risk environments, tighter controlled environments, or maybe they're environments that go around the world internationally, like ships and aircraft. So they have their own technical standard. Instead of having compliance with a certain country in the world. So you can see how you can easily get a question with that with regards to inclusive and exclusive. So one of these would be mixed in with the other. We then have 113.1 equipment. It just says regulations apply to items of equipment only so far as selection and application of the equipment in the installation. It does not deal with the requirement for the construction of assemblies. So there's a whole different array of BS standards for manufacturing. As far as BS7671 is concerned though, what we need to do is identify, when we select a piece of electrical equipment, we need to identify the environment it will be used in, the competency of the user, whether they're ordinary or they're skilled or instructed, if training is required, and most importantly, the suitability of the equipment for the demand placed upon it. Will its life be diminished in the normal selection? If we select a piece of electrical equipment and we put it in a way, or we put it into use in a way that's not optimal, and its life is diminished, then we're creating risk of fire, risk of electric shock. So we must assess for those risks and actually go backwards and select better electrical equipment. So we've always got to make sure we've selected it appropriately, and that's where equipment comes in BS 7671 with selection of equipment. We must make sure the equipment is designed and selected to suit use, normal service use, including, bear in mind you could be working with a client at quiet time. Ask where they're going to be going in 2 or 3 years. Are they planning on increasing production or increasing growth, for example? So is this electrical equipment going to be applying a lot more stress or under a lot more load in X months' time? So you need to try and get that picture when you select electrical equipment and verify that what you are selecting is suitable for service. We then have 114, which is it's interest regulation, because a lot of people still get a bit confused with it. So this is relationship with statutory regulations. It says it straight away. They are non-statutory, so the WIRE regulations are not a legal requirement. They may, however, be used in court of law in evidence to claim compliance with a statutory requirement. The relevant statutory provisions are listed in Appendix 2. So if we actually go to Appendix 2, we can see that a couple of these legislations are mentioned, just as an idea. So we have Appendix 2, Statutory Regulations and Associated Memoranda. Okay, I'm assuming you found that now. If not, I'm not going to say page numbers, 359. But just pause the video if you haven't found it yet. And it just gives us there, in the UK, the following classes of electrical installations are required to comply with the statutory regulations indicated below. Okay, so for distribution, it says the electricity, safety, quality and continuity regulations, a bit like I just said. And obviously they're looked at by the Health and Safety Executive. Buildings generally, points to the building regulations mainly. Work activities is electricity work regulations and so on. So there's a bit of information on legislations and laws and things like that, and that's a good reference point, really. All right. It then says I'm back in 114.1 now. It then says in the paragraph below, for a supply good in accordance with the ESQCR, it should be deemed that the connection with Earth of the neutral of the supply is permanent. So it's not temporary, it's not bolted, it's not screwed, it's a permanent connection. Outside England, Scotland, Wales and Northern Ireland, confirmation shall be sought from the distributor that the supply conforms to the requirements corresponding to those of the ESQCR in respect. Okay. The last bit of this, Chapter 11, Section 115, premises subject to licensing. This is obviously for installation premises over which a licensing or other authority exercises a statutory control. The requirements of that authority shall be ascertained and complied with in design and execution of the installation. I've experienced this in a number of ways. As an installation electrician, I experienced this when I worked at a high security hospital where the patients were vulnerable. Very, very popular hospital in the Crowthorne area, and we had to install we had to install some socket outlets at extra low voltage, and then we ended up having them changed from PELV to self, so we had to have them electrically separated due to the fact that these patients required access to power in their rooms, but they were vulnerable to their own actions, and so they had a rules procedure created, and they created this line that said that it'd be an isolating transformer, and some of them were allowed an isolating transformer up to the 250 volts of an isolating transformer, but some were only allowed ELV isolating as well because of extra risks. So they exercised a control over the norm, and we had to follow that. Now, I've also worked in the private food sector as a consultant, developing electrical safety rules and electrical safety procedures with companies to allow them to exercise a higher level of control. So they dictate, the systems of work, the requirements with regards to selection of components and panels and things like that. So any electricians that go to those firms, they comply with BS 7671, but they also have to comply with the rules of the company. So it might be that the company has chosen a brand of this or a brand of that, because all they're thinking about later on is what they've got to maintain once you've installed it. So they have a spec or they have a method of work that both helps them maintain in the future and ensures safe working practices when you're there. So these are examples of other controls really that you could have. We then move on to chapter 12. So this is object and effect. So, what's it going to do? What's the regulations going to do? So it says, the standard contains the rules for the design, erection and verification of electrical installations so as to provide for safety and proper functioning for the intended use. So there's a good key word there, the intended use. We need to understand how the electrical system is intended to be used once it has been commissioned. This can raise a question if, for example, you're installing a supply to an empty business unit for a landlord, and the landlord says, just put XYZ power over there. If you don't really know the requirements of the tenant or the occupier, it could be that you have to re-inspect. Something that landlords need to really consider, is they may say to a client, you have this amount of power, you have this limit of power, but it might be that a client moves in and just has to adapt or has to adjust. Previous training company I used to work for had that they had a training centre in Watford, and it was upstairs in an office, but it was it was in an office block, and so you had like sockets in the floor, the power tracks, and we weren't using any of that. We had to have extra 16 amp sockets and 13 amp sockets for the test bays, so we had to put in a new board, we had to put in a whole new load of wiring, so the actual existing subsystem was heavily underused and we had to put in something else. So you do need to make sure you know the intended use through the procedure of design. It then says, chapter 13, which we're going to talk about in a sec, gives us the fundamental principles. It does not include detailed technical requirements, which may be subject to modification because of technical developments. That makes a lot of sense when you think about the fact that this book is published every 3 or 4 years or so, whilst technical developments such as manufacturers are changing almost on the daily. So they can't go into the nitty-gritty of technical detail. What they will say, and you'll see this in a minute in chapter 13, is follow the manufacturer's instructions. So if we do that, then we can rely on the manufacturers to have that later standard test condition, that later compliance standard in the manufacturing process. And so they'll have the technical information, which we'll also collect and we'll put into our OEM, our operation manual, on completion of our electrical installation. Standards set out the technical requirements to enable electrical installations to conform with the fundamental principles of chapter 13 as follows. So it just gives us parts 3 to 7. So the assessment general characteristics, followed by the protection for safety, followed by etc. etc. I kind of covered this process in the introduction video, but it covers it throughout. Then it has this last little bit which says any intended departure from these parts requires special consideration by the designer or the installation and shall be recorded on the appropriate electrical certification specified in part 6. The resulting degree of safety of the installation shall be not less than that obtained by compliance with the regulations. And that's an important thing to understand. So if we are going to depart from BS 7671, we must verify that the departure, whatever it is that we're doing, will not result in a less safe scenario. So if, for example, a client said that they wanted that socket outlet adjacent to the bath within this boundary, that we're not allowed to have it, if it's less safe, it's a no. We can't do that. If, for example, the client was to bring a luminaire home from their holidays and we had no CE mark or manufacturing information at all, we then technically can't comply with part 5, where we need to verify the selection and erection of equipment. We may choose to carry out some inspections or some tests to determine the effectiveness of the insulations, the conductors, continuity and resistance measurements, just to get an understanding on how it's been manufactured. If we conclude it to be safe, just obviously made outside of the country, so not with the same paper trail, if we can conclude that, we may then choose, as long as the client or the architect or ourselves is happy, we may then choose to bring that in. But as it doesn't comply with Part 5, we'd have to put a departure down in the form there. And, for example, we may even put in any measurements that we've got. We may recommend at the interval of periodic inspection that this luminaire is not allowed to be sampled and it must be inspected. So we can introduce little things like that, but as it wasn't compliant with Part 5 at the initial point where we installed it, we'd have to introduce that as a departure, and it now says that has to be recorded on the certificate. Okay, so we must make sure any departures are not less safe than normal compliance with the regulations. We then are introduced to Chapter 13, the fundamental principles, which is basically a way of saying what are the basics, what are the must-have basics of BS 7671. So we must have and we must achieve protection for safety. Okay, it says 131.1, the requirements of this chapter are intended to provide for the safety of persons, livestock, and property against dangers and damage which may arise in reasonable use. So if it's used in an unreasonable way, then maybe that's not a problem. But if you're using it in a reasonable way, livestock or property must not be exposed to any risk from using the electrical system. Okay, and it gives us some examples of what we're looking at. So we have risks from shock current, excessive temperature likely to cause fire, burns, injurious effects, ignition of a potentially explosive atmosphere, under voltages, power supply interruptions, arcing and burning. So there is a number of scenarios, there are a number of risks that can occur. It's not just electric shock. We've got to think of all these other scenarios that can occur and all the risks to persons, livestock and property from working with an electrical system. And then in 131.2 introduces this principle that we will repeat a lot, especially in chapter 41. And this is protection against electric shock, 131.2. So it tells us basic protection. Persons and livestock will be protected against dangers that may arise from contact with live parts of the installation. This will be achieved by one of the following methods. So, preventing a current from passing through the body of any person or livestock. How do we do that? Insulation, barriers, obstacles, placing out of reach. Or, limiting the current which can pass through the body to a non-hazardous value. Okay, so isolating transformers, extra low voltage supplies, having safer voltages, touch voltages, bonding. But basic protection, we're actually thinking maybe about electric fences kind of thing. High voltage, very low current. The current is limited to a non-hazard value. Okay, so when we think about basic protection here, what it's saying is we insulate it so that we cannot receive electric shock. If we do receive electric shock, remember this also complies to livestock, we need to make sure that their electric shock isn't going to create harm. So we limit the current to a non-hazardous value. And whilst electric fence is bloody the current is deliberately small enough to not harm the animal. Okay, just throws them off. So that's how basic protection is achieved. So from our everyday principle, we're looking at barriers, enclosures, obstacles, placing out of reach. What stops you touching things that are live? Yeah. So that's the basic. But we also need to think about what could happen in a fault scenario. So we have fault protection to go with that. So fault protection. Persons and livestock shall be protected against dangers that may arise from contact with exposed conductive parts during a fault. This protection can be achieved by one of the following methods. So preventing the current resulting from a fault from passing through the body of any person or any livestock, limiting the magnitude of the current from the fault to a non-hazardous value, and limiting the duration of the current to a non-hazardous time period. Okay, so preventing a current from passing, resulting from a fault from passing through the body of any person or any livestock. So we have obviously typically double insulation. So if there is a single fault condition, there's another layer of insulation. So fault current will not find a way outside of that class of equipment to the person. Similarly with class 1 items or anything like that, we'll have the ADS process. We'll have the earthing and the bonding present. We'll take that current away, removing that exposed live part. But we have to combine these next two for that. So bonding is going to lower the potential. Okay, so it's going to limit the value of the fault. But we have to have the earthing to work with the bonding, and the earthing is where we actually take the fault away quickly. Okay, so earthing is all about limiting the duration of the fault, and bonding is all about limiting the value of the fault. So in a fault condition, we must have a combination of all of these as well. We're going to repeat basic and fault protection a lot, I guess I said earlier, especially in part 4. So we'll need to remind ourselves that basic is a fault-free thing. So insulation barriers placing out of reach. Fault protection is a single fault thing. So that's earthing, bonding, suitable protective devices, for example. We then have protection against thermal effects. Now, the installation shall be so arranged that the risk of ignition of flammable materials due to high temperature or electric arc is minimized. In addition, during normal operation of the electrical equipment, there shall be minimal risk of burns to persons or livestock. Now, we're going to cover this a lot more in Chapter 42, Protection Against Thermal Effects. Okay, but it then says, persons, livestock, fixed equipment, and fixed materials adjacent to equipment shall be protected against harmful effects of heat or thermal radiation emitted by the equipment, in particular the following. So combustions of stored material, risk of burns, etc. Okay, so it's a fundamental principle of the wiring systems, okay, of the electrical installations to achieve protection against thermal effects. That's why Chapter 42 is there. It's a fundamental principle to achieve protection against electric shock. That's why Chapter 41 is there. It's also a fundamental principle to achieve protection against overcurrent. It says, persons and livestock shall be protected against injury, and property shall be protected against damage due to excessive temperatures and electromechanical stresses caused by overcurrents. Okay? Same with fault current. We need to consider, when we have a fault condition, we deliberately install a circuit of low impedance to achieve a fault current of high value. The objective of that is the higher the fault current, the shorter the duration, the quicker the fault is cleared. What we need to consider, however, is when we achieve these low impedances to achieve these high currents for short duration, this high current for this short duration, can the live conductors operating limiting temperature, their insulation, tolerate this increase in current for this duration? And then later on in 54, chapter 54, we'll also be saying, can that protective conductor, if the protective conductor is being used in an earth fault, can that protective conductor actually carry that current for the required duration as well? So we'll look at the thermal gains, and we'll look at the electromechanical stresses during fault conditions. Two different areas, and that's protection against overcurrent and protection against fault current. We'll cover that one in chapter 43 later on. It also says then protection against voltage disturbances and measures against electromagnetic disturbances, and that's chapter 44. So we've got to consider any disturbances in the voltage, either a loss of voltage, an overvoltage of manual cause, such as introducing a load that's large in inductance, such as a motor, or it could be an overvoltage of atmospheric origin, such as a lightning strike. It could be an undervoltage where you've lost a phase on a three-phase motor, for example. So we've got to consider the potential losses or gains in voltage and the risks on equipment that comes with that, and we'll cover that in chapter 44. We then move on to 132, which is the design. So let's remember that this is telling you the basics requirements, and we're going to cover all of this stuff in a lot more depth as we go through parts 4 and 5. So the design, it says, the installation shall be designed by one or more skilled persons. We'll talk about the skilled person in the part 2 video. To provide for the protection of persons, livestock and property in accordance with 131, we've just looked at that, and the proper functioning of the electrical installation in the intended use. Okay, characteristics of available supply or supplies. So it gives us, right, so we're going to go through these different regulations very briefly because we're going to repeat them as we go later on. Information on the characteristics of the available supply or supplies shall be determined by calculation, measurement, inquiry or inspection. It depends on what you're looking at, really, doesn't it? You can inquire some things, you can calculate some things, so it's just an overall. So the following characteristics shall be included in all documentation: the nature of the current, whether it's AC or DC, purpose and number of conductors, so number of type of live conductors, protective conductors, the value and tolerances of the voltage, the frequency, the maximum current allowable, which is an interesting term, prospective fault current, and external earth fault loop impedance. You may know that as the ZE. Protective measures inherent in the supply, such as earth neutral or mid-wire, and particular requirements of the distributor. So obviously we need to understand how the supply is distributed. We'll look at the earthing systems in part 3. But obviously, if it's a TNCS system, we will remind ourselves quite a lot later on that whilst that's a very popular system in commercial industrial systems these days, there are restrictions on the use of PME and PEN conductors with certain types of electrical systems. Nature of demand, 132.3. The number of type of circuits required for lighting, heating, power, control, signaling, communication, and information technology shall be determined from the knowledge of the location of points of power demand. So, ask the client, where's this stuff going? Loads to be expected on the various circuits. Daily and yearly variations, that's important. So we mentioned this earlier on, is there a variation in the load? Are you there at quiet time? There's going to be a lot more demand later on. Any special conditions such as harmonics, requirements for control, signaling, communication, information technology, and anticipated future demand if specified. For safety service and standby supplies, then we'll have to consider the characteristics of the supply and the circuits that are to be supplied by the safety source. So we'll have to consider segregation and compartmentalization. We'll cover that later on in safety services section. The environmental conditions, we'll look at that in chapter 52 or through to appendix 5, but that will also tell us about the, it'll give us information in regards to IP ratings, ingress protection and things like that. Also, it'll tell us about limiting temperatures of conductors and all that stuff. So the environmental conditions are very important. Also, with environmental conditions, we've got to consider things like capability of users and building structure. Cross-sectional area of conductors. Okay, this comes up quite often in questions lately. The cross-sectional area of the conductor shall be determined for both the normal operating condition and, where appropriate, for the fault conditions, according to the admissible maximum temperature. So we must understand the maximum limiting temperature of any conductor. The admissible voltage drop. We'll cover those in section 523 and 525, so that's chapter 52. The electromechanical stresses likely to occur due to short circuit and earth fault current. Actually, I said that a minute ago, didn't I, about the levels of current in fault conditions. It's repeating itself really, but yeah, similar principle there. Maximum impedance for correct operation of the short circuit and earth fault protection. So the ZS and ZN in the case of a short circuit. Method of installation, harmonics and thermal insulation. All of this will be covered in 523 and 525. 132.7, the type of method of installation, the type of wiring and method of installation. So the nature of the location, nature of the structure, support in the wiring, etc. So if you're in an industrial environment, you'll probably go with your steel conduit, steel tray, your ladders or whatever. If you're in a school, you may have that, or you may go for trunking in a classroom or in a schoolroom. If you're domestic, you'll probably go with twin and earth in the wall, similar things like that. They must be selected to suit, though, the environment, so voltage, electromechanical stresses, and all that stuff. Then we have protective equipment, overload, fault current, over voltage. Select equipment for all of those potentials. Emergency control, if applicable. Disconnecting devices, they'll be provided so as to prevent switching and or isolation of the electrical installation, circuits or individual items of equipment as required for operation, inspection, testing, fault detection, maintenance and repairs. All of the above, really. Prevention of mutual detrimental influence. Accessibility of equipment. Documentation. Protective devices and switches. And this you'll see repeated a lot. A single pole fuse, switch or circuit breaker shall be inserted in the line conductor only. So we don't put a single pole switch in the neutral. Isolation and switching. There will be effective means suitably placed for the radio operation, provided that all voltage may be cut off from every installation. Additions and alterations to an installation. No additional alteration, whether it's temporary or permanent, shall be made to an existing installation unless it has been ascertained that the rating of the condition of any existing equipment, including that of the distributor, will be adequate for the altered circumstance. Furthermore, the earthing and bonding arrangements, if necessary for the protective measure applied for safety of the additional alteration, shall be adequate. Which means in English, when Doris goes to B&Q and buys a light fitting for her bedroom, and she goes to install it and realises she doesn't know what she's doing, she finally calls an electrician out. When the electrician realises that a luminaire is going to go in, it's going to increase demand, going to add demand to an existing electrical system, you're going to then have to consider the additional alteration to the electrical system, and you may then have to decide to go and look for the presence of earthing and bonding under her sink. And she'll then just start thinking that you're kind of trying to pull a fast one. But we must verify that if we add any demand, any impedances to an electrical system, that the existing protective measure, whether it be ADS, double insulation, whatever, is sufficient, because it must be sufficient. If it's not, and we work on the system by increasing an impedance, even maybe decreasing an impedance, which would therefore increase a fault current, that could be a problem. Adding a demand, increasing IB, that increases volt drop. Any of these things could make the system less safe if it was already not compliant. And we would sometimes have to improve measures to make it compliant for us to do our work. So that's what they're saying. We need to verify that the ADS and all the other protective measures we choose to use are going to be safe for our additions and alterations. We then have selection and erection of equipment, which tells us every item of equipment shall comply with the appropriate British or harmonised standard. In the absence of such a standard, though, there will be a reference made to an appropriate international standard or the appropriate standard of another country. So if they come and they haven't got the standard for the equipment, then you find the standard for where it comes from. If there are no applicable standards, the item of equipment concerned shall be selected by special agreement between the person specifying the installation and the installer. I mentioned this a minute ago with the departures. If there is special equipment, it has to be agreed. It then mentions underneath, if it is done, it needs to be recorded on the electrical installation certificate specified in part 6. So yeah, so that's the departure. We need to know with regards to electrical equipment, we need to know the characteristics. The voltage of the equipment needs to be suitable for the system. The current, the frequency, power, okay, equipment which is selected on the basis of its power shall be suitable for the duty demanded of the equipment, taking into account the load factor and the normal service conditions, so the expected demand of the piece of equipment. Conditions of the install, prevention of harmful effects, new materials or inventions. This one's interesting. So, where the use of a new material or invention leads to the departures from the regulations, the resulting degree of safety of the installation shall be not less than obtained by compliance with the regulations. Such use shall be recorded on the certificate in part 6. We then have 134, which is initial verification and erection. And this is very important. 134.1.1. I repeat this one nearly on the daily these days. And that is good workmanship by one or more skilled or instructed persons. We'll cover that in part 2. And proper materials shall be used in the erection of the electrical installation. The installation of electrical equipment shall take account of the manufacturer's instructions. That sounds easy. Apparently, it's not, but it should be. The characteristics of the equipment as determined in accordance with section 133 shall not be impaired by the process of erection. So the erection of the equipment shall not compromise the requirements of 133. Conductors shall be identified in accordance with section 514. 514's identification, so we'll get there later. Where identification of terminals is necessary, they shall be identified in accordance with the table in 514. Every joint and connection shall be of proper construction and will have consideration to conductance, insulation, mechanical strength, and protection. So they'll be suitable. The equipment shall be installed in such a manner that the design temperatures are not exceeded. So we need to understand the design temperatures. That's the temperatures, obviously, with regards to the equipment under load, with adjacent equipment under load. This can become a big problem because I see an awful lot of electricians take pictures of their new work, and there's a lot of habit these days where people cable tie their cables all together, and there's grouping. Grouping is becoming a big problem. People aren't understanding design temperatures because maybe they're not being told them. Equipment likely to cause a high temperature or electric arc shall be placed or guarded so to minimize the risk of ignition of flammable materials. We'll cover that in chapter 42, protection against thermal effects. We then have initial verification during erection and on completion of an installation or an addition or alteration to an installation, and before it's put into service, there'll be appropriate inspection and testing carried out by skilled persons competent to verify the requirements of this standard have been met. So a couple of things from that. You need to be skilled to know that the requirements of this section have been met. So, you need to know the regulations, and you need to know the installations you are inspecting to understand the requirements of that. But you must also do it during the erection process. Quite often, a lot of electricians or contractors will have a team that do the install and a team that do the commissioning. This can create a problem because you'll end up with limitations or not verifieds on new installations. There should be no limitations, no not verifieds. It should all be ticks or not applicables. And sometimes when we don't allow a suitable inspection during the erection process, there are many things that should have been inspected that cannot be inspected any further. And that's just unacceptable. Then there's periodic inspection. To finish, 135. It is recommended that every installation is subjected to periodic inspection and testing in accordance with Chapter 65. So it's a recommendation. The requirements of maintenance in the legislations is in Electricity Work Regulation 4.2, which tells the employer to ensure effective maintenance to avoid danger. Fundamentally, that kind of goes in full circle, and the recommendation is periodic inspection and testing. But you haven't got to do it, it's a recommendation. And that's where we're at. We're at the end now of part 1. Next video, part 2, definitions. I think that's going to be a small one. I don't plan on hanging around that one for too long, but we'll keep going in the normal pattern. So that's part 1 covered. Any questions, let me know, but definitions is next.